Hi guys, so in this video we are going to find out how to do the standard deviation for a set of data. And we're going to use the same data we did at the very beginning where we made our pivot tables, our frequency and group frequency distributions. That was our restaurant information. We had our quality rating and our meal price. If we scroll through this, you'll notice they have a lot of restaurants in this, over 200, so that can get a little cumbersome when we're looking at this. And notice as I scroll, that header restaurant quality rating and meal prices just disappears. So one thing we can do when we're working with a whole lot of data and we want to be able to keep this top row that tells me what everything is I can actually click on that row and I can go over to view. And right here where it says freeze panes, I'm just going to freeze the top row. You can actually freeze both the top row and the first column, either one of those, and you can actually select what you want to freeze as well. But we're just going to freeze the top row here. And by doing that now, when we scroll, notice the restaurant quality rating and the meal prices stays up there. So at all times, we know exactly what we're looking at. This is really good if I have a lot of data going across my graph and I get confused about what each column means. So now I can see what the columns are. So I'm going to come down here all the way to the very bottom of this so we can put in our mean. I'm actually going to go ahead and do our mean first. Remember we did that in our previous video. We're going to do equals to average. Now there's one and two things we can do. We can scroll back up to the top and we can select all the way down this row, but that was a lot of information, or we can just type in exactly what cell we want to start with. In this case, our first cell, we're in the column C, and our first cell with data in it is 2. So we're going to do C2. I'm going to do a colon, and then my last cell that I have data in is C301, and I'm going to close that with that parentheses. Notice that that entire row now is highlighted, and then I can press enter and we find that the average meal price for these restaurants is $25.8999. That's a pretty kind of ugly number there. So what we can do to make that a little bit prettier is come over here to home, and where it says general up here at the top, just down click and choose that to be a number, and it automatically rounds it to 2 decimal places, makes it a lot prettier to look at. So now let's do the standard deviation. I'm going to abbreviate this with ST and then DEV. So we're going to do equals STDEV. Now you'll notice that we have a lot of different options here. So I'm going to talk a little bit about it, what it is. If we knew we had the population, which means that we had every restaurant in a city, if we're talking about a city, or in a state, if we're talking about a state. If we know we have the entire population of restaurants, then we would use the .p. The .s is for sample. So here's the really kind of strange and weird thing. We can either do .s, which specifically talks about the sample, or we can just do the standard dev. It automatically assumes it's a sample. So either one is fine. They're just being very specific here, especially for your population. So what we're going to do is the same thing we just did. We're going to do our parentheses. Our first data again was C2. Our last data was C301. And again, that same area was highlighted for us. Going to end that parentheses and press enter. And our standard deviation is 9 point blah, blah, blah. Again, that's not a very nice number. So we're going to come up here and click that and change it to a number. And we have this 9.29. Now, remember what this means. This is the spread of the data. So if I want you to think about this. One standard deviation. Okay, that means that my data, I'm going to do a formula here, is equal to this minus this. So that's the low end of one standard deviation, or it's equal to my mean plus this. So one standard deviation means that one standard deviation away from my mean, my data is between $16.61 and $35.18. So $16.61 or $35.18. That is one standard deviation. And what we typically talk about with standard deviation is that we feel that about 60% of our data lies within that one standard deviation if our data is what we consider normal or symmetric. It's got that nice bell-shaped curve. We can do the same thing for 2 standard deviations. except this time when we do this, we're going to multiply our standard deviation by 2. So we'll do our mean, our mean minus 2 times our standard deviation. Okay, and then we'll do the same thing here, and we'll do our mean plus 2 times our standard deviation. And again, let's change these guys to numbers because those are not very nice there. So within 2 standard deviations, that means that I expect my data to go from $7.32 up to $44.47. And we expect about 95% of our data to fall within 2 standard deviations of our mean. And then we could go out to 3 standard deviations. 3 standard deviations, we expect about 99% of our data to fall within 3 standard deviations. And it would look the exact same way. I would take my mean and I would subtract 3 times my standard deviation, and then I would take my mean and add 3 times my standard deviation. But again, remember, standard deviation is just talking about the spread or how far apart the data is. And then we can talk about 1 and 2 standard deviations away from our mean. Guys, we're starting to get to the point where we're going to talk about how to determine if things are significant. And the way that we determine things are significant is how many standard deviations something falls away from our mean. Okay? If I want to say, I want to be 95% confident that my numbers are going to fall within 2 values, that means there's a 5% chance that it's going to fall outside of those values. Okay, so then if I have a restaurant in this case that falls below $7.32 or above $44.47, I can say that that is outside of that 2 standard deviations. That's abnormal because there's only a 5% chance that that's going to happen. And we're going to talk more about that in the next chapter. I just wanted you guys to have a basic understanding of what standard deviation is. If we want to find variance, by the way, this is the one time where we go backwards instead of finding the variance first and then finding the standard deviation. On this, what we're going to do is we're just going to take this particular cell, that's our standard deviation, and we are going to square it. You want to do shift and the 6, it's going to give you that little caret guy, and then do a 2 for squaring, and then we have our variance. Again, that's a horrible number, so let's just put that as an actual number, and our variance is 86.26. We don't use variance a whole lot because it's the square of our data and it doesn't make a lot of sense compared to the mean, whereas the 9.29 or $9.29 above and below the mean makes a little bit more sense to us. I hope this helped, and if you have any questions about finding the standard deviation or the variance, please let me know.